Welcome to lesson number 5. We're going to look at factoring binomials in the form of a squared x squared minus b squared y squared. And if you take a close look, this is factoring by difference of squares. So if I have the expanded form of this, because we have a difference and we have the same binomial other than the operation between the two, we will cancel out our middle term. And so the shortcut would just be to write my factors as perfect squares. And so then if we were factoring something like this, we'd be taking the square roots, and so we would have ax minus by and ax plus by. So let's put this into practice with class example number 1, where I have 9x squared and 16x and 16y squared. So first of all, we know we're going to get a binomial here. Square root of 9 is 3, square root of x squared is x, square root of 16 is 4, and y squared is y. And I know that this factor will repeat. These factors will repeat over here, but it will be positive. Over with this example, there's a term that I can remove first to make it a perfect square. So first of all, they're both divisible by 3, and they're also both divisible by x and y. So I'll pull out an xy, which would leave me with x squared minus 9y squared. Here's my difference of squares I can use to factor, and this will be x minus 3y, x plus 3y. With class example number 2, this is a pretty interesting one. We're told that we have a longhouse, and the longhouse, they were dwelling places for Squamish peoples of BC as well as Tsimshian and Haida and Haisla. And so, yeah, we've learned a lot about longhouses here at Centennial, but if you want a little bit more information, you can follow this QR code, and it'll take you to a URL. But we have a longhouse, and they can be disassembled and moved to new locations. And this particular one has an area of 49x squared minus 16y squared. And we're told that the length is double its width. So that'll be important later on. First thing we want to do is we want to write the length and the width of the longhouse in the form ax plus by, where a and b are integers. And we want to determine the appropriate values for a and b, and then write expressions in x and y for the length and width of the longhouse. So first of all, we're told that the area is equal to 49x, well, it looks like an a, 49x squared minus 16y squared. If we were to factor this, this would become 7x minus 4y times 7x plus 4y. This represents the area, so the length and the width. So my length is double that of the width, which means it's larger. So we know that the length has to be 7x plus 4y feet, and the width needs to be 7x minus 4y feet. Minus 4y feet because it is smaller. The longhouse, it has a perimeter of 56 meters. It's reassembled. And given that the length of the longhouse is double its width, we wanted to make a strategy for determining the length and the width of the pane. So there's going to be two expressions we're going to be working with here. The first thing, let's think about the perimeter. So the perimeter is 56 meters. And we know that if we're given the perimeter or are looking for the perimeter, then that's going to be of a rectangle is going to be the 2 times the length plus 2 times the width. The perimeter is 56, and my length is going to be 2 times 7x plus 4y plus 2 times 7x minus 4y. That's my width. If I expand this, we're going to distribute our 2 into everything in the brackets. We'll get 14x plus 8y, and do the same thing over here, and we're going to add 14x minus 8y. Here what we'll see when we simplify is that those y terms are going to cancel out, and we're going to get a statement that says 56 is equal to 28x, and a value of x will give me 56 divided by 28 a value of 2, which will equal x. So now that we have this information, what we're trying to do is we're trying to determine the actual length and width of our longhouse. And so we have a value x, but that's not really enough to work with yet. So what we need to do is we need to consider that my length is going to be equal to 2 times the width. And so our length is 7x plus 4y, and that's equal to 2 times the width, which is 7x minus 4y. If we go ahead and expand this, we're going to get 14x minus 8y. And if we expand this again and simplify like terms, what I'm going to be doing is going to bring everything over to this side. So 14x minus 7x is going to equal 7x. And then negative 8y subtract 4y is going to equal negative 12y. And this is all going to equal 0. Now, the reason we're doing this is because I have a value for x, and that's 2. And so if I plug my value in for x here, I'm going to get 0 is equal to 7 times 2, or 7 times 2 minus 12y, and I get a value of 14. And if I bring my 12 over to this side, that gives me 12y is equal to 14. I'm running out of space here, but here, let's pop it up over here. The value of y would be 14 divided by 12, or 14 over 12, which is equal 7/6. So 7 over 6. Now we can determine the actual length, and let's make another little box here. But length is equal to then 7x plus 4y, or 7 times 2 plus 4 times 7 over 6. Length would be equal to 18 2/3 feet. The width would equal 7x minus 4y, or 7 times 2 minus 4 times 7/6. My width would then equal 14 minus 36 would be 9 1/3 of a foot. So there we have our lengths and our widths for our longhouse. Now we're moving on to class example number 3. So in class example number 3, we have our difference of squares method, and we're going to be using the process of substitution again. And so with the process of substitution, if we have a binomial written in this form, x to the power of 4 minus 16 y to the power of 4, notice how x4 can be written also as x squared, and y to the power of 4, or specifically 4y to the power of 4, can be written as 4y squared. Now this will help us with substitution, because we could then instead substitute a and b in for our terms that are perfect squares. This will just make things easier in the long run, as we'll see in this example here. So over here, k to the power of 4 minus 1, I could say let a equal k squared, for example. And if I do this, I'll substitute my value a in for k squared, which would be something like this, a squared minus 1. And if I have a squared minus 1, then I can then rewrite this as a minus 1, a plus 1, which would just be k squared minus 1, k squared plus 1. Now, I still have a difference of squares here, so k squared minus 1. We could rewrite just this part as k minus 1, k plus 1, and then I still have my k squared plus 1 term right there. Yeah, I'll do class example 3c. So I got 2p to the power of 5, q to the power of 4 minus 162 pt to the power of 4. Now, the first thing I'm going to do right off the bat is I'm going to get rid, I notice I have like a exponent 5 here, power 5, and so I'm going to get rid of one of those p's, and as well as this p here, just so I can make this a little bit easier to work with. So I'll divide 2 out, so 2 and p. This will leave me with p4 q4 minus, and because I took out the 2, 161 divided by 2 will be 81. Now I got a perfect square there, and t4. So you don't have to use substitution here. Like you can if you want. And I typically like to use substitution, but for this example, I'll just do it without substitution, just to give you another idea of how to do this. So 2p, I know that I can raise both of these to a second power. So instead of p4, q4, this could be p2, q2 to the power of 2 minus, if I, again, raising this to the second power, this would be 9t squared to the power of 2. And then 2p will be equal to, well, we now have our difference of squares that we can use. So if we're using difference of squares in this case, then this is just going to expand to p squared q squared minus 9t squared times p squared q squared plus 9t squared. So these represent our factors, right? And so those are the ones I'm kind of like doubling up. And now we can simplify whatever is a perfect square again, which is this one here. We would have 2p times pq minus 3t, pq plus 3t, and then this extremely long factor binomial, which, well, I guess it's not that long. It's just a lot of squares going on there. And this would be our final answer.